condition. Okay, fine. Now what we are going to do is like an application external varying force. Okay, it will be, look at that joint connecting spring and block. So like both the springs.
Where forces acting towards the spring.
Let it be, it doesn't matter. I'm telling you, no. Compression and elongation both are same. Okay, I'll do one. Okay, fine. If you're so much of worried, I'll change it. For me, diagram will become very constrained. That's why I'm taking help of this one. What you have to do is like, look at that point P, the joint, no, which is there. And now how these two springs are there in series. So definitely, what do you expect the elongation in this spring? As the elongation in this spring is x1. What about the elongation in this spring? Because the block is moved by a distance x, no doubt. The block is moved by distance x. So now look at this one. So definitely the springs are in series. So the elongation in this spring should be equal to elongation in this one. And what is the P? P is a massless, no? It is a massless, like some joint, and the whole spring is light. The springs are massless. So net force on the point P should be 0. Springs are light. This is very important for us. Springs are light. So net force on any point on the spring should be 0. So what is the elongation in the spring? 1, let it be x1. Elongation in the spring 2, let it be k2 x2. So therefore here first we'll write k1 x1 equal to k2 x2. Any reason for that? Net force on point must be 0 as springs are like, this is a reason, like from this is a major point of the problem here. Why spring force must be equal? Because springs are light. Springs are having mass, you can't write this equation. What is the total elongation? I think x equal to, what is x? X is the displacement of block. Means altogether, this spring will elongate, this will also elongate. The sum of elongation of these two should be equal to displacement of block. So let's solve this one. X equal to x1, x2 will be k1 x1 by k2 x2. Similarly, x2 equal to k1x by k1 k2. Okay, these are the elongations in individual springs. Elongation in the springs then block is displaced by x. No. First, work done by S2 on the block, work done by F on the block. All this we have to calculate one by one. And now first one, work done by the spring 2 on spring 1 will take it. I'll start work done by S2 on block. Let's explore the option A. Work done by S2 on block. Work done by the spring force 2 on the block that is being asked. So this should be equal to WS2. What is the force acting on the block? K2 X2 spring, work done by the spring S2 on the block. I think S2 means it's, I understood spring 2, no? In the diagram it is there. So what is the force exerted by the spring on the block? The spring K2 X2 only, because this end of the spring is connected to the block. Then how much the block has undergone displacement? X dx. But do we know X2? We have calculated that. So substituting this K2, K1X. Mm-hmm. Oh, fine. Okay, this will be K1, K2, X square. Okay. Check any option is there. I'm not
Sir, it
visible.
should be minus half K1, K2.
Negative work, no? It does negative work. Yeah. Any option is there? K1, K2, X square, 2, K1, K2. Okay, A is equal to Q. We'll write like this. Then work done by S2 on S1. Okay, let me scribble here only. Work done by S2 on S1 means by spring 2 on spring 1. Okay, this will W12, I'll write symbol. What is the spring force? What is the spring force here? K2 X2, and it will make the point P to undergo displacement X1, and in turn K2 X2 is equal to K1 X1 we have here. So actually this is the method 0 to X1. How much of point will undergo displacement by X1? So what is we have? K2 X2 it is. Now we can't integrate. So X2 can I replace in terms of K2 X2 can I replace in terms of K1 X1? Yes, it is K1 X1. So this will become K1 X1 square by 2. What is X1? We have here K1 by 2. This is the one part of the thing. Work done by S2 on S1. Any option is there? K1, K2, X square. S is there. What about the work done by F on the block?
Sir, you mark Q instead of S.
Okay. Yeah. Work done by S1 on the wall. This should be 0, no doubt, because wall will not move. The spring force will act on the wall also. The wall will not undergo displacement. Okay, fine. So this one, last one, work done by F on the block. This applied force. What is effective spring constant K, no? They're in series. Then what is the displacement of the block? X. So can I replace these two springs by one equivalent spring? And what is work done by applied force now here? work done by applied force. Here only it's quite simple. What is K? K1, K2 by K1 plus K2. Any option is there? K1, K2, X square by. Okay. For C, R is there. Effective spring constant. They are in series. Effective spring constant. K1 plus K2. Any reason why we should write like this? Because springs are in series.
Sir?
Huh.
Sir, why have you taken the work done by S1 block as negative, sir?
How this spring force will act here? Why don't you look at here? K2, X2. Because this is also getting elongated, no? Here K2, X2 will act, no? Because what is the elongation, the spring? The spring force will act at the ends and that
Yes,
will
sir.
act towards center. K2, X2 will act here. So
Yes,
it does
sir.
negative work on the block. Huh?
Okay, sir.
And I'll show it here. Okay, fine now.
Yes, sir.
Make observation, I'll scroll down. See, all the numericals, we have to put some effort, not like some formula is there, I'll apply it. Even, sir, everyone knows conservation of mechanical energy. Those things, now we know standard, everything, that one, but we have to understand the numerical, what is involved, what's actually going on. Then it'll be very easy. Now everyone knows integration, everyone knows conservation of mechanical energy, and everyone knows the spring force. But here the situation, you see, drawing diagram, analyzing it, what is the situation given, what is the idea involved. Definitely this is called like a problem solving. This will, nobody can help you unless you help on your own. Teacher will show you some numericals, like this you should think, like this you have to think, but again a problem will come, again there a student has to think. So students now what they are like, they are thinking that teacher will teach so that we can solve any problem. Then tomorrow I'll teach for donkey also will solve and all the problem, not possible, no? Even if I teach, after listening to my class, again you go and start doing problems, again you have to struggle. Are you getting? So it's a wrong impression that like a teacher will teach, okay, it'll become very easy. Okay, teacher is guiding you here. See, like this situation comes, you should think in this way. Again, when you go for problem, what all teacher has taught, that ideas may or may not help to some extent. But what all we have done, no, these are some all basic fundamentals. Like this you have to think, like this you have to think, like this you have to think. A problem may come. There are 10% of numericals where what all I thought, no, may not applicable. You have to really understand the situation you have to apply there. I think you might have seen such situations when, especially in physics. That's why the role of physics teacher is very less for the students getting rank. So I'll never say that, okay, I produce rank, because what I'm only 5 or 10% is what I'm helping. No? The remaining everything is what student individually is putting effort, thinking, analyzing. So some are under